In part B of the first titration problem, a weak acid with a strong base, we need to find the pH after 50.0 milliliters of base is added. Now remember that we know that this base in the problem happens to be 0.800 molar sodium hydroxide, so now we have a volume to go with the concentration. At the beginning of the problem, we were told that we had, for the HA, the acetic acid, that we had 250 milliliters, that's 0.250 liters, and we multiply that by its concentration, which is 0.45 molar, which is moles per liter. And we find out that at the beginning of this, before we did anything, we happen to have 0.1125 moles of acetic acid, of the HA, the weak acid. Now this is important because this is what we're neutralizing. So when we're in the beginning part of the titration curve, we are neutralizing, and when I put in my hydroxide, I'm going to now have 0.050 liters times 0.800 molar, and that's going to equal 0.0400 moles of hydroxide added. The hydroxide neutralizes the same amount of the acid. So I just do a subtraction and I find out that after I add that hydroxide, I now only have 0.0725 moles of HA left. So my concentration of the acetic acid is now the moles, 0.0725, divided by the volume. Well, what's my volume? I started with 250 milliliters, I added 50 milliliters, so I have a new total volume of 300 milliliters, or 0.30 liters. So moles per liter, that's molarity. My molarity of acid is 0.242 molar. The concentration of my acetate ion, the part that's left over, relies on the fact that for every one of these hydroxides that neutralizes an acid molecule, it leaves behind the A-. So that means that my concentration of acetate ions is the same number of moles divided by the same total volume, and that equals 0.133 molar of the A-. Well, now, if I need to find the pH of a system that's got both of these in it, it's just going to be the HH equation, pKa plus the log of the A- over the HA. So that means the pH equals the negative log of the pKa, the Ka, which was 1.8 times 10 to the minus 5, so that was given in the problem, plus the log of this ratio. A- on top, 0.133 over HA on the bottom, 0.242. I plug this into the calculator, and my pH is 4.485. 3 digits after the decimal because I had 3 digits in every number given to me in the problem. Keep in mind that when we are doing these, we are looking for certain key parts. to remind you that we did at the origin. We've done something along here where we're not at the equivalence point yet. I know I'm at the equivalence point when the moles of added hydroxide would be the same as the moles of the original acid. So until this volume gets big enough to make this number the same as this, I am below the equivalence point. Now there's a sweet spot where I'm halfway there. And when I'm halfway there, pH equals pKa. So I'm halfway there when I have half this many moles. And we're going to see that show up when we get to part C.